So good morning one and all. Myself Dr. Bachu, Associate Professor, HOD of ECE. The last 5 sessions we discussed about the probability theory. Now we will discuss the random variable concepts. When an experiment deals with the outcomes are non-numerical in nature, so that case we are using the random variable. Means we are assigning a real number to each and every outcome of the sample space of the random experiments. Right. The today's session, the presentation outline, we will discuss the random variable, the conditions for the function should be a random variable, the types of a random variable. So this is a today's class we will discuss. Now in this part B, apart from the classification of the random variables, we will see the distribution and density of the random variables, and we will discuss the different types of the random variables, their density and distributions of binomial, Poisson, uniform, the Gaussian, exponential, the Rayleigh random variable. And we will define a conditional event, methods of defining conditioning event. So what is the conditional distribution and density, their properties. So this is the part B of the unit 1. Today we will discuss only the random variable, the conditions and types of the random variables. Now coming to the definition of the random variable is a rule or a function assigns a real number to every element of the sample space to the random experiments. Why I need to go for the random variable? Let us take experiment, the random experiment, for which experiments the outcomes are non-numerical in nature. That cases we are assigning a real number to every element of the or every outcome of the sample space. This is a random variable. The random variable can be denoted as the capital letter X, capital letter X, or it can be denoted as capital X of S. S means here S is the sample space. So we are assigning a real number to every element of the sample space, and that assignment should be unique. Assigning a real number, okay na, to every element of the sample space. That assignment should be unique. So it is a random variable. Now coming to this one, is also known as a stochastic variable. Random variables can be called as stochastic variables. The random variables notation uppercase letters X, Y, Z, etc. And the values whatever we are assuming are assigned, them are denoted by the lowercase letters with subscripts x1, x2 like this, small x1, small x2, x3, etc. This assignment the range from minus infinity to the plus infinity. When you see one example, consider an experiment rolling of fair coin 2 times. The sample space S of this experiment consisting of the following events. These are non-numerical in nature. So that are here head, tail, the tail, the tail. Now assigning the real number to every element of the sample space, that should be unique. It's called the random variable. Like this, capital X takes the value 0 if the outcome is head, and takes the value 1 if the outcome is tail, takes the value 2 if the outcome is tail, takes the value outcome is the tail. Then X is said to be a random variable defined over the sample space. Clear? Are able to follow? We are assigning a real number to every element of the sample space. This is for 0 for this outcome, for this outcome, for this outcome. These all assignments are unique. So like this way we are defining random variable which experiments are outcomes are in non-numerical nature. Graphical representation of this random variable. Now this is a plain it seems. Okay na, we have some events in the sample space, distinct possible outcomes that are events in the sample space, mapping to the real axis. This is the real axis. Okay na, and this assignment should be the unique, like that manner we are assigning. So this is a graphical representation. Now what are the conditions? Are there any conditions for a function should be a random variable? Right, we have some conditions for a function should be a random variable. Always the function should be a singly valued, not a multiple valued. The function should be singly valued. Whenever you are assigning a real number to every element of the sample space, that should be singly valued. It's not a multi-valued. The set x less than or equal to x, the set capital X less than or equal to x, small x is assignment, and capital X is the random variable, is an event for every capital X. That is, it is equals to the sum of the probabilities of all the elements. Events correspond to the capital X less than or equal to small x. If any event is there, x less than or equal to small x, you have to take the probabilities of these all the elements correspond to the x less than or equal to x. And next, the probabilities of these events is equals to infinity, it is equals to minus infinity, be 0. Means the probability at infinity is 0, the probability at minus infinity is 0. So these three conditions must satisfy the when we are defining a random variables. These are the conditions for a function should be a random variable. Then it is the proper random variable. Then we will see the types of the random variable. Types of random variables. The random variables basically classified as continuous random variable, the discrete random variable, and a mixture random variable. Like in sample space we saw continuous and discrete sample space. The same manner we will see the one by one the discrete random variable first. If x is a random variable which can take a finite number, or countable finite number of values, then x is called the discrete random variable. Discrete, the countable number, like as a discrete time signal. Experiment. An experiment where the pointer and a wheel of chance is spin, the possible outcomes are from 0 to 12 marked on the wheel. The sample space is S is 0 less than S less than or equal to 12. Start from the 1 up to 12. These are marked on the wheel. My random variable is capital X equal to S square, or x of S equals to S square. So where S is means nothing but as here, okay, now events here. When it's shown on the wheel, it seems 1, it's 1 square, 2, 2 square, 3, 3 square, 4, 4 square, 6, 6 square, like this 12, 12 square. So this we are mapping on the, okay, now this we are mapping on the real axis. This is my real axis. Now this is mapping is there, na? It's we are assigning a real number to every, okay, na, element of the sample space. That should be the unique. The unique values are here. 1 means 1 square, 2 means 2 square, 3 3 square, 6 square, like so on, 12 square. So these are called, okay, now real values assigned to the random variable. So this is your random variable how we are mapping. This is one of the example of the discrete random variable. Now continuous random variable. A continuous random variable is one having a continuous range of, means it contains infinite number of values, okay, now within one or more intervals. It is referred to as the continuous random variable. Example, measuring the height and weight of the persons. It is a continuous. Within some interval it is varying. Like mixed means as a mixed random variable is one for which the sum of its values both either of the discrete and continuous. It is called mixed random variables. This session we discussed about random variable definition and the conditions for the function should be a random variable, the types of the random variables. Clear? So these things we will apply to the, okay, now your distributions and densities, and further the standard random variables we will discuss in the further session. Any doubts you can send a mail to the HODC@mlratm.ac.in. Thank you for your cooperation. Thank you.